Hi, welcome to Automotive Appreciation Part 3. In this section we learn about superchargers, turbochargers, carburetors, fuel injection and diesel engines. On the intake stroke we want to get as much air into the cylinder as possible. Air intake can be improved by pressurizing the incoming air with a pump driven by the engine. The pump is called a supercharger, and in this case a roots blower is used. This system improves air intake. However, the belt-driven blower takes power from the engine. A better option is to use a turbocharger, which is driven by the waste exhaust gas. A turbocharger uses the energy in the waste gases exiting from the cylinder to spin a turbine which drives a compressor mounted on the same shaft. The compressor draws clean air in through a filter and compresses it. Unfortunately, compressing air also heats it, resulting in expansion. It's best if this air is cooled with an intercooler before entering the engine. As the turbo spins at high speed, up to 150,000 revs per minute, the bearings are lubricated by oil. The oil reduces friction and removes heat from the turbo. When a cold engine is started, it should not be revved until the oil has reached the turbo. Likewise, a hot engine should idle for a short period before turning off, allowing sufficient time for the turbo to slow down before the oil pump is turned off. As we require constant boost pressure from the turbo, it is common to use a variable geometry turbine. The vane angle can be adjusted depending on exhaust gas flow. At low gas flow, the vanes are in the closed position. As the gas moves through the small gap between the vanes, its velocity increases, thus increasing the turbine speed. At high exhaust gas flow, the vanes are opened, thus reducing gas velocity. At low speeds, the vanes are again closed. Other ancillary equipment include a wastegate. It is used to bypass some of the exhaust gas from the turbine when it is not required. ABOV. Blow-off valve or dump valve is used to vent pressurized air to atmosphere when the throttle valve is closed, thus preventing damage to the compressor. It tends to make a whoosh sound when it activates. Exhaust gas recirculation, EGR, recirculates a small amount of exhaust gas back to the inlet under certain operating conditions. This reduces the amount of oxygen in the charge and helps to reduce combustion temperatures and emissions. When fuel is stored in the fuel tank, it will emit a vapor. To comply with the emissions, this vapor is not discharged to atmosphere. When the engine is not running, the vapor is collected in a charcoal canister called the EVAP, Evaporate Emission Control System. When the engine is running, the EVAP valve is opened and the vapor drawing into the engine and burned. An engine will not have to have this ancillary equipment, as some items are used for similar tasks. Also, some are more suited to diesel than petrol engines. A common problem with turbos is turbo lag. When the engine is accelerating, there is an increase in airflow through the engine and thus through the turbo. However, it takes time for the turbo to spool up to speed and develop the required boost pressure. This time delay or turbo lag is noticed when accelerating. At mid-range we get a surge in power as the turbo develops boost pressure. A variable geometry turbo helps to reduce turbo lag. Early engines used a carburetor to mix petrol and air together. Air is drawn into the engine by the pistons on the intake stroke and the flow is controlled by the throttle. The narrow passage creates a Venturi effect and draws fuel into the airstream. When the fuel level drops, the float moves down, thus admitting more fuel from the tank. Ideally, all the fuel should atomize, break into small droplets, and mix with the air, but some will condense on the inlet manifold. Disadvantages include poor mixing of the fuel, inaccurate fuel metering, difficulty with cold starting, and high emissions. This system has been replaced with electronic fuel injection. With electronic fuel injection, EFI, a pump is used to pressurize the fuel, which is atomized by the injector as it enters the inlet manifold. An electrical solenoid is energized by the ECU, which determines the quantity of fuel required. There are various layouts for the fuel injectors. Single point, one injector is used for all cylinders. Multi-point, an injector is provided before each inlet valve. The fuel is sprayed as each valve opens. And direct injection, the fuel is injected directly into the cylinder. A fuel rail stores the petrol at high pressure, and the ECU provides the signal on when to spray the fuel into the compressed air. Similar to the timing of the inlet and exhaust valves, it is possible to adjust the timing of fuel injection depending on speed and load conditions. So far we have dealt with SI or spark ignition engines. A diesel engine is called CI or compression ignition engines, as they rely on the high pressure charge to self-ignite and don't need a spark plug. When the piston is near TDC, diesel is injected directly into the cylinder and ignites the hot air. Diesel engines operate at a higher compression ratio, are heavier in construction, provide good torque, and are particularly suited to turbocharging. Here we show the operation of a fuel injector. Fuel enters through this pipe and some flows into the small chamber above the needle through a small orifice. This high pressure fuel keeps the injector closed. When the ECU, electronic control unit, energizes the piezo crystal, it expands and the valve moves down, releasing the pressure fuel in the top chamber. The high pressure fuel moves the needle up and the fuel is injected. When the crystal is de-energized, the valve closes and high pressure diesel closes the injector. On a modern car, there might be 3 phases of injection: pre, main, and post-injection. This provides a controlled burn of fuel, reducing noise and increasing power and efficiency. The pressure in a diesel common rail system can be up to 1,500 bar. We hope you learned from automotive appreciation.